All right. Oh. Hello, everyone. It is I, Cale Royer. I am not Hans, as I'm sure some of you can tell, and I'm sure some of you cannot tell because you have no idea who Hans is. That back there is my future brother-in-law playing with my baby. You can ignore them. Thank you for joining us for this webinar. We've got a great presentation from another man who actually is not Hans, but is Travis Vickerson, who works with Hans at New Jersey Crane Expert and also has his own consulting firm, Noble Oak Safety and Training. So Travis Vickerson is going to be doing this one. The simulator is currently in use, but he's got a lot of great information. As always, if you have any questions, go ahead and put them in the chat, and I will ask him throughout, and we'll get all your questions answered. At the end, there will be a link that I'll post in the comments section that will take you to a quiz. And if you pass that quiz 16 out of 20, you will get 2 free CEUs from ISA if you are doing it within the next about 24 hours. After that, you can still watch the videos here on Facebook and YouTube. You can still take the quiz, but the quiz will only get you 1 CEU. And that's my baby over there. Right next to the cat. There's just absolute chaos in here. So I am going to stop talking and throw it on over to our host tonight, Travis Vickerson.
Thanks, Cale. It's a pleasure to be here. No, I am not Hans Thielman, as some of you know, but I do work with Hans. So Hans actually and I work for a company called Noble Oak LLC, and Noble Oak has got 2 different companies involved in Noble Oak, and there's NJ Crane Experts, this company, and then there's Noble Oak Safety and Training, which is that consulting firm that Cale was talking about, and we'll talk a little bit more about that later. But tonight we're going to talk about crane operational awareness and really kind of looking at crane operation. We know it's growing in the industry and what we can do to kind of make yourself safer, make your crew safer, but also make your crew a little bit more knowledgeable and hopefully a little bit more efficient. So I really am glad to be here. I hope everybody's enjoying some dinner while they're watching me. If you're on the East Coast, if you're on the West Coast, it's probably about 3 o'clock your time. You're probably getting ready to get off work. So hopefully you can watch me once you get off work or watch me later. So anyway, my name is Travis Vickerson. For those who don't know me, I've been in the industry now 20 years. I was also a full-time fireman for the city of Durham, North Carolina Fire Department for 15 years. I have an extensive background in education for the last 10 years. I've taught at TCI Expo, ISA chapter conferences, ISA International, and also was the co-author for several BMPs, one of them being the Crane Operations BMP from TCIA, the 2nd edition that came out. So super excited to talk about cranes. I love cranes. I think they're super cool, and also I think they're one of the coolest things that we can use in our industry. So talking about cranes, we got to understand some things that we know. Right now, we understand crane use is growing rapidly. We're seeing a huge uptake in cranes entering the market space. That's happening for a lot of reasons. One, it's because we're starting to get smarter about the way we work. So we're working more efficiently and using our equipment better. We're also kind of changing our job sites by doing this. So when we're out looking at work, now instead of thinking of everything as a hand removal, we have this option for large equipment removals. So that's also kind of changing some things. We're seeing some new hazards that come into the marketplace. So a lot of operators are buying cranes now, really don't understand some of the concepts behind cranes. They're not necessarily certified operators, and that creates some difficulties as well. All right. There's also some new regulations that have come out, and there's new regulations coming out as well, especially when we start getting into the remote control stuff. But altogether, what we're really finding out with cranes and tree work, it is the safest, most dangerous way to do tree work. And I'll explain that a little bit. So the safest for the climber, absolutely hands down, it is the safest way to do tree work. Because instead of gravity always trying to take things to the ground on you, you're going to use that crane to lift the material up and away from you. So that's a very safe way to do it. It's a very static way of doing crane work. We want crane work to always be static versus negative rigging situations or even positive rigging situations where we're using rope. That's a more dynamic situation. So that kind of helps us with that. It's the most dangerous though from the operator's perspective. For crane operators, when you're picking up a load that you're not exactly sure the weight on, it becomes extremely a dangerous venture. When you're picking up like an AC unit, or you're picking up, say, a roof trusses, or even if you're picking up a piece of metal they put into a bridge like that, you have the weight. It's a calculated weight. You know what it's going to weigh. And also, if you pick it up off the ground and you don't like the way it's rigged, you just put it back down. But in our industry, we really don't have that option. So if I'm operating a crane and my climber's up in the tree and They sling me to a piece and I'd say, yeah, I'm good for 2,500 pounds. But they cut it a little big and it's 4,500 pounds and I start to pick it up and things don't go well. I can't put it back down and have them cut less off or cut more off to weigh less or have them adjust their rigging slings. Because once I'm hooked to it and it's cut free, the crane operator owns the piece at that point. So that's why we say it's the safest, most dangerous way to do tree work. Safest for the climber in the tree, but hands down dangerous, most dangerous thing that you can do as an operator. Some other things we understand that our cranes are changing, right? We're seeing new tools come in the marketplace. This here is actually a knuckle boom with a wire hoist mechanism in it. So it's super cool. You get all the advantages of a knuckle boom with an articulating boom crane where you have multiple articulating sections. You've got multiple extendable sections. So you can kind of unfold right in your workspace, go to work, reach in and do things. But you also get the advantage of that wire hoist, just like you do on a boom truck or an all-terrain crane. So there's some different things going on with that. So now you've got a new machine that's incorporating both tools, and there's huge advantages to that. There's also some difficulties with that. So as operators grow in their understanding, they have to understand that the equipment's changing as well, and you can't operate this machine like you could say an Alltech AC45 127 boom truck. It's not going to operate the same way. No different than if this was a knuckle boom without a wire on it. A knuckle boom is going to have different advantages and disadvantages than a boom truck or like say a link belt 90-ton all-terrain crane is going to have. So every crane's a little different, and how we use it's a little different. What we understand about our job site safety, though, is we have top 4 incidents. Our top 4 incidents right now in the industry start with our struck bys, and that's struck by either parts of trees or whole trees. So that can be in crane work. Say we're picking a piece and you haven't really attached it really well, and a piece breaks off. So say maybe a sling comes around and knocks a branch out, or you didn't have a really good attachment and that attachment breaks out and the whole piece falls. You can have it struck by that way. Right? You can have slip, strips, and falls. We all know that happens, right? Getting on and off equipment is where we see a lot of this occur from not having 3 points of contact. So here we really want to ensure when we're getting on and off our cranes, especially a lot of our cranes that have got flat decks to them, those are not really walking working surfaces. So like think of a knuckle boom crane, for instance. A knuckle boom crane that's a mid-mount crane or a rear mount crane may have a substantial deck area near that crane. Well, that crane deck area is not designed as a walking working surface for you to work off of. So we see slips, trips, and falls from your operators who have remote control, and they're operating, they're looking around, doing their operation. They're not paying attention to the edge of the decking there, and they have slips, trips, and falls from decks. Right? Electrode contact, that's huge in the crane industry because essentially we're operating giant lightning rods. We've got a big piece of metal up in the air, and we get usually a wire hanging from it, or we got live vegetative matter hanging from this crane. When we get that within close proximity to power lines, we have the high potential there for an arc. Right? So we understand in crane work, we always need to maintain 10 feet of distance from the crane and the load which the crane is holding away from power lines. And that 10 feet is that air gap distance. So we understand air has resistance. And we want to make sure we maintain that resistance so that the electrical arc can't jump through the air and hit our crane or hit the load that it's suspended from, or even worse, come in contact with our climber. Because there have been situations out there where a crane has come in contact with power lines, has energized the crane itself and has fatalities and injuries, and has also energized the tree which the climber was in and had fatalities and injuries. So we need to be careful of those things. Lastly, we have vehicular. That can be most likely driving the job sites, but also happen on our job sites for how we set our job sites up. So these are our top 4 incidents that we're seeing in the industry, right? And we understand how we do things to prevent these from occurring. A lot of these things are incidents, they're not accidents. An accident implies you did nothing and something occurred to you, where an incident takes a stance that something happened to create the bad outcome. One thing we understand about our world, though, is we're trying to create repeatable outcomes in an unpredictable environment. Every tree you do is always different. Every job site is different. I don't care if you go to Miss Johnson's house 10 days in a row, it's not the same day. The weather's different. Your sleep the night before may be different. Your exhaustion from the day before may be different. The job changes, the trees change. So every day is a new day, and we're trying to create these outcomes in this unrepeatable environment is very difficult for us. So we have to look at our PPE. That's one of our number ways we stay safe. So we look at our PPE, the PPE that we're required to have at all times doing tree care, whether it's in a training setting or in the field doing work. Even if you're doing your job walk around, your job site briefing and your walk around, you need to have your PPE on. And that's our helmets, our eye protection, our ear protection, and our foot protection. And of course, we want chainsaw protection when we're operating a chainsaw on the ground per the Z133. And we also want to wear high vis when we're exposed to traffic, and the right high vis classification based on the speed of the road that which we're operating near. Right? We need to make sure we have job briefing in place. A job briefing is crucial to having a safe work site. The job briefing helps identify our hazards. It also lets us know the work that needs to be done, what precautions we need to take in doing that work, if there's electrical hazards and how we mitigate those hazards, our assignments of work, and the PPE required. All right, we use the NIOSH hierarchy of controls for this. Whenever we have a hazard, we have to look at either eliminating the hazard by removing it from the job site, mitigating the hazard by how we do our work, protecting our workers from that hazard, and then lastly, our PPE. And then a big thing with crane work is communication. Communication is paramount when it comes to crane work because most of our situations, we've got a crane boom up in the air, maybe 120, 140 feet of boom up in the air, and we're picking a piece that may be 90 feet in the air, and you operate on the ground can't directly see what the climber is doing aloft. So it takes extreme good communication here to have very cohesive environment so that each person knows what the other person is doing at all times, and that helps eliminate a lot of our situations where we have potential for incidents. So a job site briefing, there's all different ones out here. There's one from TCIA. It's a great job site visual inspection. It also helps us really understand our tree structure. We look at our critical risk versus high risk and low risk. We look at our species. We look for our site and conductors. And this can actually be found in the Tree Care Academy Crane Operations Specialist book from TCIA. It also can be found in the BMP for tree care, for crane work in tree care, second edition, which you can get from TCIA as well. This is a really great thing to use. The one thing I would add to this in the remarks section, if you're hoisting a climber, we want to make sure that we document why we're hoisting a climber, because OSHA really isn't happy with us hoisting climbers in tree work. They're actually not allowed to do it unless you're using a man basket, but we don't use man baskets. So the way that we're allowed to do this per the Z133 is it has to be the safest option for us to do our work. So you need to make sure that you document why this is the safest option. For me, that's usually fairly easy. The crane is the only rated attachment point that my climber can use in the tree. Trees don't have ratings on them, but our crane does. So that gives me a rated anchor. So I have a highly rated anchor point for my climber in the hoisting situations. So we want to make sure we document that correctly. Hand signals for crane operations is also huge. We need to make sure that we have these available. Our hand signals are supposed to be displayed on all cranes and job sites. Per the ASME B30.5 states you have to have hand signals on the crane. And we want to make sure everybody understands the hand signal. The one we see most often for stop is this. Doesn't actually mean stop in the crane world. Stop actually is moving your hand back and forth like this. That is the correct stop technique. But a lot of times we see our hand held up like this. Now again, if you and your operator have come to a consensus on your hand signals, and they may be different from these, but you understand them, then that's fine too. But we need to make sure we have our good communication to have good, effective job sites. And we got to make sure we stay clear of electrical hazards. Electrical hazards can be very dangerous. As you can see from these two photos here, they are extremely dangerous to work around. We have an individual on the left who's taking an extreme risk by putting a communication wire in their mouth, and an individual on the right here who actually, unfortunately, did not survive this incident from indirect contact with a limb being rigged out into power lines. So we need to be very careful around electrical hazards. A lot of these things we can't walk away from. So when we talk about electrical hazards, we understand per the Z133 document that there are 3 types of line clearance qualification in our industry. For those who don't know the Z133, this wonderful document, you can actually get this in a digital version from ISA, or you can get it in the actual printed version. It's only $15, fairly inexpensive, and you actually have all the standard right here in front of you that OSHA is going to use in the event that you have an incident, or if you have questions about some of these things, like our line clearance qualifications. So our line clearance qualifications, there we go. All right, I'm not sure exactly what happened there, but all right, cool. So our line qualifications, we're supposed to have some animation there that didn't quite occur, but we understand that we've got non-qualified, qualified incidental, and qualified line clearance. The difference being here for non-qualified means that you have not had adequate training for electrical hazard awareness, you have not had first aid CPR, and you've not had your annual aerial rescue training. All these things must be documented and verified by the employer. And then it's actually the employer's job to qualify you as line clearance qualified. The difference between our incidental qualified and our qualified line clearance, though, is based on who you're working for. So if you're doing residential work and there happens to be a house drop or a distribution line that comes through the property that you're working for, then you're working as an incidental line clearance arborist. If you're working for the utility company, though, you may be on a residential property, but you're actually working for the utility company, then you're a qualified line clearance arborist. And there's some differences there in what you can do and how close you can get to the wires. So if you want more information on that, please check out the Z133 in section 4, and you'll get all that information there. Setup is huge. We want to make sure that our setups are good. If we have a bad setup in a crane, we have a bad day. We have to understand that no matter how strong our crane is, it is only as strong as the ground in which we set it up on. So a bad setup can equal a bad day, as you see here. This crane actually was set up too close to a foundation. We had some undisturbed soil that had kind of got compressed throughout the workday, and this ended up causing a catastrophic failure of a tipping here. So the crane didn't break, it just flipped over on top of this house and another house next door. Not a great day, and it's not really a great way to get referral tree work. You can see here where the outrigger actually pressed through the soil. There looks to be a basement in this house, so I don't know the exact history on this. It looks like it compressed in the soil and fell in. There may have been a collapse of the foundation wall inside the basement area. I don't have that information, so if anybody has that information on this, they'd like to tell me, I'd love to know about it. I just happened to see these pictures that somebody sent me from social media. And we can look at there, and we can see that the outrigger completely pressed into the soil. We lost that, and over we went. So we need to understand how we do this. How we set our cranes up is crucial to our day. One thing that most operators don't understand is how much weight they're actually displacing. So on our crane, when we're up and we're picking things, the whole goal, if you imagine my arm as the crane boom and my load is hanging here in my hand. The idea is this load is transferred a measure of force up through the wire to the tip of the crane. This lever is now creating force generated back to the center pin of the crane. That force then is distributed to the chassis of the crane, which then distributes it to the outriggers into the ground. Now in a knuckle boom, it's a little different because the knuckle boom has stabilizers, not outriggers. But for our conversation here, we're going to focus on outriggers. So as that force is exerted on those outriggers, it's exerted to the ground in pounds per square inch. So when we look at this, we have to understand how much pounds per square inch our crane is displacing. So for example here, this crane that we're talking about here has a GVW of 79,370 pounds. That's how much the crane weighs by itself. No load, just by itself. And this crane's going to have 4 outriggers. Plus we want to add in the heaviest pick. So when we do the math on this, we come out to 29,842.5 pounds per outrigger potential. Meaning at some point, if they're looking at a 10,000 pound pick with this crane and they move that pick over top of one outrigger by itself, therefore single point loading that one outrigger, it has the potential to generate 29,842.5 pounds of force. All right. So then we understand our outrigger pad has got 576 square inches of area that it's covering. So it's translating that 29,842 pounds and it's dispersing it over 576 square inches. When we divide that out, what we end up with is 51.8 pounds per square inch being administered to the soil. That's really good if you're on mixed granular or you're on concrete, but that would be horrible if you were on lawn, asphalt, or a clay silt soil. Because here's our soil bearing capacities. So on soil such as lawns or undisturbed soil around foundations and such, you're looking at 22 psi. So for our same crane, if we had the exact same configuration with 29,842.5 pounds on that one outrigger, we have to have more than 576 square inches of displacement to get down to that 22 range. We have to almost double, more than double, our square inches. So we need somewhere around 1,000, 1,200 square inches of soil bearing to get us down to 22 psi for that exact same crane to be set up on a lawn versus being set up on a driveway that's concrete. You also see here that you have asphalt at 29 psi in the picture here. This picture I actually took as a link belt 90 crane that was operating on a construction site down in Knoxville, Tennessee. Throughout the day, the outrigger was pushed down on a hot day, and the asphalt heated up, and you can see the indentation here. And I don't have a pointer. Oops, sorry, went the wrong way. I don't have a pointer, but you can see the line right underneath that cyclone fence. That's where the outrigger had been sitting earlier in the day and actually depressed the asphalt. So we can have a failure there. You can see here in a granular soil in the second picture where this single outrigger with no dunnage underneath it, no disbursement for PSI, just was able to push the pad straight into the soil almost like a fence post almost, right? So we want to make sure that we understand our soil types. I highly encourage you to find out what your truck weighs, find out what your max pick is for the type of work you do, know that number by heart, and then know what kind of dunnage you're putting down, how many square inches of dunnage you're putting down, maybe through plywood or, timbers or Altura mats, or, even there's usually crane experts. We actually sell mats to put under your outriggers for displacement. So you can come to us for those as well, for specifically built for cranes, not for like bucket trucks. And you really want to know that you're going to be good in all soil types. Concrete here, 1,000 psi. That's on an 8-inch pour, so you're looking at most likely a foundation like a garage floor is going to be an 8-inch pour. Most driveways aren't 8 inches. Most driveways are somewhere between 4 and 6-inch pours. So you need to have a little bit less PSI there, so you want to displace that as well. But this is why we never put our outriggers pads directly down on our surface like they did in the top picture. We always want to put something there to displace the setup, like you see here. Here we've got a link belt 90 crane. It's being dispersed out in multiple different configurations. This is actually the same crane in both pictures, 2 different job site setups. On the picture on the left, you can see where the outrigger is put out. It's put onto a 4x6 timber that's blocked straight across, and then that 4x6 timber sitting on an Altura mat, because we were on a soil that we figured was a lawn type soil. So we want to make sure that we could disperse as much load out as possible. Versus the left side rear outrigger has the same 4x6 timbers that's actually pushing down on a gravel driveway. So we know we had a gravel situation there that's going to be a little bit harder, a little more PSIs, versus the right rear outrigger that's going to be in that lawn setting. The pictures on the right side of the screen can show us that, we have a little bit more setting of an off the driveway, but we still were in hard clay soil. So this is here in North Carolina where we've got a really good clay soil, and we knew we were good for that kind of space there and that kind of pressing. We also understand what our timbers can handle. So when we look at our cribbing and our timbers, we have to understand what they can look at. I prefer Douglas fir as my timber of choice. Douglas fir has a 500 PSI shear strength, so it's fairly strong, but also it has some give to it. Give's really important as an operator, because in the event that I overload my cribbing, I'll start hearing it popping. I'll start seeing it give before it just fails. So I like knowing I've got a 500 PSI shear strength in my cribbing here. From here, we have 2 different sites of cribbing. We've got a kind of like the old school Lincoln locks, where it's a 3x3, where you have 3 this way and 3 kind of on top, creating 9 points of contact. Those 9 points of contact equal 54,000 PSI of support before you break through those timbers. And on the right-hand photo, you can see here where it's actually blocking, where it's the same 4x4 blocks, but they're put edge to edge longwise. And that actually creates a 5x5 solid layer, which generates 150,000 pounds of PSI. So we have to understand how we build up. Again, our crane can be the biggest crane in the world, but if it doesn't have a good foundation to stand on, it's really not going to matter. Sometimes you have to get kind of crazy too to level our cranes. So here is a crane that was getting leveled. This is a Heartwood Tree Service out of Charlotte, North Carolina, where they were leveling their crane. They had a pretty steep place where they had backed off a driveway on the Altura mats, and they had to use really long cribbing in order to get high enough, because the rule of thumb is you can only go as high as the timber you have. So if you have a 4-foot long timber, you can only go 4 feet high. So if you need to go higher than 4 feet, then you need to have longer cribbing. So here they actually have 8-foot timbers in place, then 6-foot timbers, and then 4-foot timbers. And then on top of that, they've got the spacing mat and kind of pushing it all down there. On the bottom right-hand side of the screen, you can see some looks like 1x8s. Those are called toe boards, and we use those to kind of fill in gaps where there's soil's not exactly perfect to get that level, because we really want our outrigger dunnage to be level, because if our dunnage is level, our crane's going to be level. We also understand what setback, though. Setback is any time we're going to put our outrigger down near something that's underground. So it could be a foundation wall, it could be a retaining wall, it could be a driveway culvert, a water line, an underground vault such as a septic vault or a propane cylinder. In these situations here, very much like when we take a rock and we throw it into a pond, our rings go out equally. It disperses equally out across the water. So as it's dispersing out equally of force, we need to make sure that we're far enough away, because that force is going to build up like a wave. So as that force pushes out, it's going to build and build and build on a center point and then continue pushing out, and you can have a collapsed wall like you have here on the right-hand side of this photo. So for known depths, it's a 1-to-1 ratio. So if we have a foundation that's 4 feet deep, our center of our outrigger needs to be, the edge of our cribbing that we put down needs to be 4 feet away. If it's an unknown depth, it needs to be 4 times the widest part of our ground support. So if we're using a 4-foot long, matting material or cribbing material, then it's 4 times that for an unknown depth, because we're not sure of. So all things that come into our setup. After setup, we need to look at our safe lifting. Our rated capacities are huge. For people who are operating cranes right now that don't believe they need to be certified as an operator and for tree care industry, that's not exactly true. It is true if you are only picking up raw organic materials, i.e. logs, trees, and those things, no, you do not have to operator license or operator certification per the OSHA exemption. But if you're picking up a live person or picking up a machinery, if you're running a knuckle boom with a grapple saw on it, that's machinery. At that point, you have to have a certified operator to operate that machine. The reason why this is so important is that a certified operator goes through a course where they learn how to interpret and use these charts that come with a crane to understand it. What we know in this chart here is that really dark black line that kind of cuts diagonally through the chart. The top of that black line, if you exceed those weights above the line, you're going to break your crane. If you exceed those weights below the line, you run the risk of flipping your crane. The reason being is because that vector force angle. So again, if my arm is the boom and the hoist cable is hanging straight down, the bifurcating angle between the two is a force vector. If that force vector is too low, meaning it lands outside the footprint of the crane, that's where you have the flip potential. If it's higher and your vector is more straight line within the frame of your outriggers, that's where you have the braking factor. So it all has to do with our boom angle to understand that. Hold on, let me get some water here. Whew. And Kale, please interrupt me if we have any questions. Just pop on in and interrupt me. So now we understand how to set our crane up. We understand how our charts work. We understand what we can pick up and what we can. Next, we have to understand what we're actually lifting. What's really kind of cool about trees is we can do the math on the left-hand side of all these different, angles and measurements and all that, or we can go old school. So Leonardo da Vinci, this really cool guy from way, way long ago, had this theory called symmetry in nature. And what his theory is, and I believe it holds true, is that daughter branches cannot exceed the diameter of the parent branch. So on our photo on the right here, if you look at the base of this tree where the stem comes out of the ground, that diameter of wood cannot be exceeded by the two branches off of that. So when it goes up and splits on that first split, if you add those two measurements up, it cannot exceed that of the base. So what that means for us is we don't actually have to know all the weights of the tree. All we need to know if we're going to pick the bottom half of this tree is, well, if say we're going to just, all the branch structure is already gone and we're going to pick the very bottom of the tree where the two splits are at. All we have to know is what the main stem section would weigh in a 10-foot section, multiply that by the length that we're picking, and that can give us, based on our green log weight chart, or if you have your phone, there's some really great apps on your phone for green log weight charts as well, called Log Weight Pro. Give you all this information, and then you can kind of figure it out. And you can do the same thing with branch structure. So as we go up our tree here, and we go to the left side of the tree, that left side branch structure that goes out the very far as left. Again, all of those branches out there cannot exceed the union in front of them. So if we go to the end of the branches and take that and smash it all down into one big glob, and took all those diameters individually, those diameters cannot exceed the parent stem in which they come from. So again, we don't have to have the weight of the entire thing. We know if that whole left side where we're making the cut at the base where it meets the other stem is 10 inches, we know that all the way out the end can't exceed 10 inches. So all I need to know is what a 1 foot by 10 inch piece weighs, and then multiply that by whatever the length of the piece is, and you have a pretty accurate weight there. Now, obviously, we got to take into account foliage. We have to take into account rain, water consumption. We have to take into death of the tree, decay, and all those things. But this gets you a fairly decent number. And with cranes, we always want to go small. Nobody ever died from going too small, but they died from going too big. So for me as an operator, my first pick of the day, I usually go really small with, because I want to get a judge for the tree. If I think it's going to be a 500-pound pick, and we pick it and it's a 250-pound pick, well, that tells me the tree's light. If I do a 500-pound pick and it comes in at 750, that's going to tell me the tree's very heavy. So I want to make sure I've got plenty of capacity to make sure we can handle that. And then I kind of adjust from there. And I always run my chart about 75%. Next, we have what we hook to the tree. We have our slings. Your slings are required by OSHA to be on at all times on anything you're lifting with a crane. So you can't use an old rigging rope. You can't use an old climbing rope. If you have an old crane sling where the tag's fallen off, you can't use that anymore for crane work. It has to have this on there, and you have to have these specific 4 identifying factors. You have to have its capacities for use, and usually these capacities are configured in 3 different ways: vertical, choker, and basket. In our industry, 99.9% of the time, everything we're going to be doing is going to be under a choker fashion because we're going to be cinching off to a branch structure. Vertical would only be accurate if you took an eye bolt, drilled an eye bolt in a tree, brought your sling down and clipped it into the eye bolt and then clipped it into the crane. Now it's in a vertical configuration. So pretty much everything we do is in a choker. We also don't do a lot of baskets because baskets don't stabilize. So the piece would just sit inside this basket that's formed, and the piece could roll and twist and move, and then we really don't want that. It's not very secure for tree work. Next, you want to know what material it's made out of. We also have to have the code or stock number for this specific crane, for this specific sling. So in the event of an incident that occurs, we can track this sling back to the manufacturer to see if there was a defect in the process of making it. They can pull other slings out for service, recalls and those kind of things, and then the manufacturer ID. After that, we have our sling, we have our connections. Lots of different connections on the market, but the one thing with the tree care industry is per the Z133 5.7.6, hooks must have a working safety latch or be locked during tree care operations. Meaning you can't have any type of hook that has a freely opening gate because you have the thing called dynamic rollout where the sling actually can come up and over the gate and open it on its own. So we want to make sure we use locking gates or locking shackles. The shackles here on the bottom are 3 different types of shackles. The first one on the left is a screw shackle that has a cotter pin in it. That's a locking shackle. The middle one is a simple screw shackle that has no locking mechanism, so you wouldn't be able to use that. And then the last one is actually a quick connect or a quarter turn spring loaded shackle, and that's a positive locking shackle as well. If you wanted to use the middle one, simply take a zip tie, run it through the hole, and go back to the shackle and zip tie the shackle pin to the shackle, and that also kind of helps prevent any issues. The other thing we got to make sure is we don't exceed 120 degrees. That's a critical angle. So you can see on the Crosby sling or shackle on the left-hand side, it has 2 45-degree markers. We want to make sure our crane slings stay within those 45-degree markers equaling that 90 degrees. We don't want to start going past that or pulling in 120 degrees because we can fail our shackles. Your shackles also must be stamped with how much they weigh and what they're good for and their working load limits. So you can see here these are 30-ton on the left-hand side. That's a fairly heavy-duty shackle. After that, we want to look at our angles. Angles are everything when it comes to crane work. So as you see in the diagram here, as our angles go from vertical to flatter and flatter and flatter, eventually what ends up happening is we're actually putting load bearing on our load. So as our slings come down and get flattered to our load, we're actually taking our load and we're squeezing our load together. So we get to like a 30-degree angle like this, we're actually can almost have 1,000 pounds of weight on this sling, 1,000 pounds of weight on this sling, and 1,000 pounds of crushing force being included into our 1,000-pound load. So we want to be very careful about that. Our ideal sling angles are usually around that 60-degree to 45-degree angle. We don't want to get less than 45. So you may be wondering, well, how do we avoid that? We run longer slings. So I know a lot of folks out there like running short slings. Short slings are fine, but you may find with knuckle booms, Hans and I both agree that you're running 30, 40, 50-foot long slings and knuckle booms is much more advantageous for these angles versus a wire stick crane or a boom truck crane with a wire hoist on it. You may be able to get away with a 30-foot sling for those. My sling choice is always a deadeye sling. I like deadeye slings more than anything else. I like it as a climber. It's very lightweight, easy to maneuver. I have lots of options for attachment, but make sure you have a sling that's going to work for what you're doing as capacity, because that's very key. If our sling can't hold our load, then it doesn't really matter how strong our crane is. Speaking of our crane, it's really important as an operator to make sure we do our inspections. You really don't want to have a day where your crane falls over in somebody's house. So inspections are very crucial. We need to make sure we have an annual inspection done by a third party that's documented. You need to have regular inspections that are quarterly or monthly, and then daily inspections as well. These are all things that are covered in an operator certification program if you haven't had it. You also can contact companies that do this. We actually can help you kind of help navigate this and all that. We've got some app-based services for type of inspections and whatnot, so we can help you with that if you're struggling with these things. As an operator, it's very important that you understand your hand signals, because you may have somebody new on your crew, or you may as a climber also need to understand hand signals if you use a rental crane. So if you rent a crane that comes with an operator, that operator is going to go with these hand signals. They're not going to take the industry accepted hand signals. They're going to take their industry accepted hand signals. So you need to make sure you understand these hand signals very well. The problem with hand signals I have as a tree worker is they take my hands. And usually as a climber, I've got what in my hands? A chainsaw. Well, I can't run a chainsaw with one hand. It's a two-handed saw. Therefore, I'm a huge fan of radio communication through Bluetooth headsets. I find it works way better. I keep both hands on the saw. I keep my situational awareness, and I can talk directly to my operator in real time. and not have to worry about, make a cut, stop, make a hand signal, make a cut, stop, make a hand signal. So it's a little bit more efficient there. The other thing I like about using radio versus hand signals is I can be very specific about my communication. So as my operator is moving, I can be very clear with them about how we want them to move, right? But as an operator, it's really important to make sure that you have integrity in your operation. We don't want operators lying to us. So if an operator if I say, hey, I've got a piece that's probably 3,000 pounds and they can only take a piece that's 2,000 pounds, they need to be truthful with me and tell me these things. If they don't tell me the truth that's going on, it makes it very difficult as an operator to do that. We also want to make sure we don't operate over 75% capacity because we understand in our industry, we need that wiggle room in case something's heavier. We get into some old growth. We get into maybe even concrete in a tree that overweights the tree. We get into a situation where maybe there's extreme water uptake. All of those things come into play. And lastly, when we're hoisting a climber as an operator, we want to make sure we're operating at 50% capacity. That's a safety factor for a personnel lift. It's also an OSHA requirement. Getting back to communication though, these Bluetooth headsets are great for this. So this is one brand of Bluetooth headsets. There's lots of different ones on the market. Find one that works for you. But as a climber and an operator, these are crucial. For me, as an operator, I want people to count me down. So if you want me to boom left or boom right, it's boom left. 3, 2, 1, stop. Versus boom left, stop. Because as an operator, I want to know when I'm going to be stopping so I can go ahead and slow my progression down. If I stop really quick on a wire boom truck or a boom truck crane or an all-terrain crane, that load's going to be swinging really hard. Not as big of a deal as a knuckle boom, but I still want to count down. Maybe it's boom up, 3, 2, 1, stop. Cable down, 3, 2, 1, stop. These simple things of communication will make you more efficient and make your job sites way better. Operators, we also need to be very leery of when we hook up to things. One of the easiest mistakes I see in tree work is pre-tensioning loads. So when we pre-tension a load, there's two different ways we can go about doing this. The first way we can go about pre-tensioning load is simply pulling up on the hoist cable. If we pull up tension on the hoist cable, that's great, but it creates deflection in our boom. So our boom is straight when it's not under a load. When we apply a load to our boom actually curls just enough. Well, that curl also creates further radius. So now our load is moving away as it's curling down. So for operators, if you want to pull tension in tree work, I actually like a 50-50 split. I'll pull 50% of the tension I need for my hoist cable, and then I boom up for the other 50% that I need. And I try to pre-tension my loads with about 75% of the load I need. So for this pick here, if this is a 2,000 pound pick, I'm looking at my LMI, my computer, I'm going to pull tension till I get about 1,500 pounds on my 2,000 pound pick. Because what I don't want is when my operator cuts it through, I don't want to sit down on their saw, collapsing, the cut and sticking their saw in there. But I also don't want the piece to come skyrocketing up. The goal is, as I cut the piece as a climber, that piece should stay perfectly still and not move. I put my saw away, and then the operator picks the piece up and move. That's a static lift, and that's really what we were trying to shoot for. So again, pre-tensioning, 50% with cable, 50% with boom up, or as you need to. Now, climbers, I'm going to talk specifically to you for a little while. Our tie-in methods are very important. This is not an OSHA-approved tie-in method, nor is this an OSHA-approved attachment for the end of this individual's crane. So we're very specific in how we tie in. You can't go tying in this way. There's lots of different opportunities and options out there in the market space right now. I highly encourage you to look at some of these options right here if you're looking to start how you want to tie in. All different ways, but the biggest thing here is we want to make sure that our tie-in point moves our rope down to at least halfway down the load overhaul ball or two block. If there's a multiple part line going on, we want to at least be halfway down. Preferably we want it where we're almost even with our hook, because the other ANSI regulation on the picture on the right hand side, you see it here, you have to actually put your lanyard, your climbing lanyard, as a second tie-in point. You could use a rope as well, but you have to have a second point of attachment going to a suspension point on your harness while being hoisted. So you have your primary line, your climbing line through a setup like you see on the screen, and then your secondary attachment point, which for most people is going to be their lanyard, goes through the throat of the hook and then goes into the lower D rings or goes into their bridge, and that's a second point of attachment. All these things you want to make sure. We've actually had fatalities where climbers didn't have that second tie-in point while being hoisted. There was a failure of equipment on the climber side that resulted in a fatality. So again, we want to make sure we move that tie-in point down to at least halfway down the ball, if not 3/4 or all the way down the overhaul ball. We want to make sure we have that second point of attachment. In the event that you do have your attachment point above the overhaul ball, what you run the risk of here is a lot of metal contact with your rope, where you have sharp metal could cut your rope, could damage your rope. It also can make it very difficult to retrieve your rope out once you're done being hoisted. There's nothing more frustrating than, you get all your slings set, you lower you descend down to the position you want to make a cut in, you pull your line out, and you begin pulling your line from the crane, and your line gets stuck. And now the crane operator's got to boom, got to cable down, try to get the ball back to you if they can, so you can get it unstuck. So that's another reason why we want to encourage you to get down and make sure you have those good bend radius. If you're going to use a rigging ring like some of the photos in the middle here, we want to make sure that our rigging ring's big enough for that bend radius. If it's not big enough, do the option that these have of using 2 separate rings. Those 2 separate rings, again, create that bend radius that we need with our ropes. Too tight of a bend radius, we could have compression and tension issues within our ropes. Next, we want to look at our cuts. So different types of cuts we do. Cuts we want to stay away from are our dynamic cuts. So these are going to be a dynamic like slide cut, or I've heard it called a salami cut. You want to make sure you stay away from snap cuts in crane work. Again, these are dynamic cuts where the crane operator has to induce something to create movement. Really not ideal. What you want here is either like a static shelf cut, like shown here, or we can even get into, V cuts or sawdust cuts like this. So the V cut, I'm not sure if Mark Chisholm actually is the creator of this. I believe he is the creator of the V cut, so I'll give him credit for that. But it's a great cut because this allows you to make 2 horizontal or 2 vertical or angled cuts that come together that allow the crane operator to have a lot of movement side to side so you can free your saw. And it also traps the butt from moving left to right once the piece is cut free. So once that piece is cut free, it's trapped in there. You can stow your saw, get yourself in a safe position, then the operator can pick it out. Another favorite of mine is a sawdust cut. I like a sawdust cut especially for the base of the tree. And what you do here is you bore cut in, and instead of using the bottom of the bar, you use the top of the bar and you walk the bar all the way around while leaving the center of the bar, the tip of the bar, in the center of the tree. So you bore cut into the center of the tree, and then you just walk the saw all the way around. And what this does is it shoves all the sawdust into the kerf of the cut, creating this big pocketed layer of sawdust. What that's going to do is that's not going to allow the piece to come sit down on your saw. You can pull your saw out, stow your saw, and then the operator can pick the piece out. This is another option to also keep your saw from being bound up. So as a climber, we definitely got to make sure we know these different kind of cuts and different ways of being secured. Now, ground workers, got some things we got to talk about too. Ground workers really need to understand the concept of operational areas. Operational areas is any part of the tree that's going to be suspended and where it can reach or it has potential to reach. So here in this diagram here, the top diagram, we've got a radius of 34.1 feet from the crane. That load now has potential to move in 34 feet around the crane, meaning you can't be underneath that load for 34 feet around the crane. So that's kind of now a drop zone once that piece is suspended. But we also have that boom deflection where you have the potential where it can bend and that load can now move further away, or the piece could rotate and you have branch structure now that can go out. So yeah, the center of the tree is 34 feet away, but our actual potential is 58.3 feet away because we had that potential area. The rule of thumb being very simple, you cannot touch that piece until it gets to chest level. So as soon as the material has come down to chest level, then you can manipulate it, move it around as you need to. Really don't want, it's really funny as an operator, you see your ground crew standing with their hands in the sky looking up like they're going to grab the piece and move it for you. And you're like, I'm a crane. I've got this. I can pick it up and move it as I need to. You don't really need you over here moving it around for me. So make sure the crane does all the work and have really good communication and understand where you're at. At any point in time when these trees are being moved by cranes, you could dislodge hangers, you could have broken branches coming out, you could have wildlife even dropping out of trees. So you really want to make sure you stay clear of those areas. Other problems ground crew may deal with is the ball, the overhaul ball, or the slings as the piece comes down. As that piece comes down, it's going to want to rotate and turn and twist and do all kinds of weird, crazy things. When that happens, you have a high potential to hit yourself or get other people hit. Z133 makes it very clear. Only one chainsaw operator should be working with that piece at a time once the piece comes down. We want to make sure we keep that situational awareness where we don't have a bunch of chainsaw operators running in because one person may make a cut or a relieving cut on a compression or tension piece that causes that piece to roll and twist. So then you don't have good communication. You could have a struck by injury there. We also have the potential for struck by the crane ball. I'm a big fan. Unfortunately, in this photo, you can't see it very well. But I take my slings off, and I actually like the crane to pull the slings out. I don't want to actually fight to get the slings out. I'm lazy. But I want the crane to pull the slings out. So what I'll do is I'll have everything attached. It comes to the ground. I'll go ahead and take the slings apart leaving it underneath the load, and then I'll have the operator either boom up if it's a knuckle boom or cable up and pull the slings out. What this does is two things. One, it lets them pull them out slowly, which applies tension to the cranes. That's a good situation. Also, it gets that overhaul ball up above everybody's height before the sling comes free. Getting hit by the slough sling is way better than getting hit with that 350-pound overhaul ball there you see in the top of that photo. So we want to make sure that we use our equipment smart and carefully, and we communicate what's going on at all times. Don't be the individual in the photo here that just walks away and doesn't pay attention to the guy leaning on the rake who's going to get hit in the back of that overhaul ball. So things we have to know. We have some very simple rules of rigging. Four simple things we know. We know our crane capacities. That's a given. We should know what our loads weigh, or at least approximately what our loads weigh. That's also a given. We have our sling capacities. We know what our slings are good for. And we also should know our soil PSI. So our unknown, and the biggest thing that we deal with at all times, is our center of gravity. Center of gravity is going to be huge in tree work with cranes. Unlike picking up AC units that have rigging points attached to them, or picking up I-beams that have very specific lifting spots for balance, trees don't have any markings on them. So it's sometimes kind of hard to find that center of gravity, and it's always going to be in play. So here in this photo here, you have three different attachments. The easiest way to remember this is at any point where the sling angle goes vertical, when the piece is picked off, the butt is going to swing that same direction. So as my piece is tied off here on the photo on the left-hand side, the sling goes around the tree and then the sling goes vertical. The same side of the tree that it goes vertical on, the butt is going to swing to and it's going to kick over, right? Unless you use two chokers, like the center photo where it's a balance pick and then it's going to come straight up. This is very important, especially if you're the chainsaw operator making the butt cut and you're near a house, you're near a fence, or just yourself. You want to cut that and get away from that because that is going to induce swing. If you need to control that swing, a good advantage here is using a modified V cut where you make a V on one side, the kick side, and you make a flat cut on the non-kick side. So on the sling vertical sling side, you make an angled cut, and then on the flat other side, you make a flat cut. And what this does is it won't allow the piece to kick because it's got that vertical cut there and allows the operator to move the piece away. Or you can use a tag line to control this as well. But really, we were always looking for center of gravity. If you can get good enough to balance a log like the one in the bottom left photo, that's great. But generally, we want two slings of attachment. And with our two slings of attachment, what we want is we want opposing attachments. Meaning if, we'll call it sling one comes down and goes around the piece clockwise and attaches, we want the other thing to come around and go around counterclockwise and attach. Meaning they're opposing forces which won't allow the piece to twist. We really want to make sure we do that on all branch structure, tops of trees, and those sort of things. We have spider legs where we can have multiple attachments. However, with spider legs, we've got to be careful. A lot of people have this theory that if we add more slings, we get more capacity, and that's not true because we use the principle of a triangle. So if we have three slings that are rated for 10,000 pounds together, adding a fourth sling does not rate it for any higher. It's still rated for 10,000 pounds because it's always going to be balancing within that triangle. So make sure that we, if we go over three slings, we're not going to be getting any capacity. We may get some stability in it, but we're not gaining any capacity. For me, I'm a huge fan, again, of dead-eye slings. I run 3 dead-eye slings. Haven't really found a need to run more than that yet. I'm sure the situations can be out there, but just be cognitive of what you're doing. So I really appreciate your time. Kale, I don't know if we have any questions. I'm going to go and throw up my last slide where you can contact me if you have any questions or visit our websites. I love educating. I love our industry. I love, working with individuals, tree workers especially. I left a 15-year career firefighting job to just be in tree work because I love tree work so much, and that's why I really think that you can only be good at something unless you love it. If you need to reach out to me, please feel free to email me at travis@whynoble.com. You can visit our website at njcraneexpert.com or whynoble.com. And you also can find my videos on YouTube under the name Travis Vickerson. Lots of tree stuff videos and some personal video montages up there of some work I've done. And with that, Kale, hopefully we've got some questions. Or if not, I think you had a steak you said it was getting cooked. You can go eat.
I do. I can hear it right now, but I do have a couple questions,
Yeah.
and I'm sure more will be coming in as we do the question and answer session because it always does. The first one is from Mark Gadet,
Hey,
Jamboo
Mark.
champion Mark Gadet.
Yes.
So when you were talking about hoisting climbers. He
Yeah.
said, where would you attach the setup in a two-block scenario?
So what you're talking about there is like a two block or a multi block setup, Mark. Those are going to be very crucial. What I suggest is in the standing leg. So there's always going to be a standing leg. You find whichever the standing leg, the non-moving leg is, and attach it there. Also, look in a two block scenario. A lot of two block scenarios have an independent pendant hole that you can use for attachment there. Put a shackle to that pendant hole and use it that way. If neither one of those are an option, your best bet actually is going to be to go off the top of the tip of the crane where the pendant attachment is up top and use that. But most of your bigger blocks have a actual little eye hole on the side. You may have to actually look in the block kind of laterally to see that, and there's going to be a pendant hole in there that you can put a shackle in and run it off that.
Um, Yes, I know. Sorry. Of course, my
Hi,
baby
Wells.
chooses right now to come in and start talking to me. I don't know exactly what you were talking about because I have never used a crane before, but I'm sure
Yeah.
that's great insight. The next one is from someone. Actually, the next one's more of just a heads up. Gary Thacker. Yeah, Gary Thacker is going to be in Raleigh next week and wants to go fishing. Um,
Ah, hit me up, Gary. We'll go, buddy.
Jordan Teelman, someone you might know, while you
Ah,
were
my
talking
boss.
about the sawdust cut, she said two bypass cuts makes the X cut. I don't know if she was talking about your V cut that you were talking about, or
Yeah, so what she's talking
uh,
about here is she's talking about the V cut, and where you bypass your cuts makes the X cut.
okay.
The X cut's a great option. I don't really love the X cut. I've got myself in some bad situations with it, so I like the V cut better. But there is the X cut where you bypass your cuts, and that one of the reason why a lot of people do the X cut, Jordan, is it gives a little bit more movement on the piece. So you actually can pass by the piece with the saw, getting the saw away from it. And that's really good if you have really big wood. But if you get into smaller wood, you actually can cut all the way through, and then you have potential for a break off, like a slide off cut, like almost like a breaking slide off cut.
That sounds like it's a discussion that you guys have been having for a while now. Phil Renaud says slings or chains.
Ooh, that's a tough one. I know a lot of climbers that love chains. I know a lot of climbers that love slings. I like slings for two reasons. One, I think they're easier to work with and give me more options for attachment in the tree. Also, I don't want to get hit by a chain in the tree. That doesn't sound fun to me. Chains are heavy, they're bulky. Also, chains don't have any give to them. So when we talk about static versus dynamic loading, the only place on a crane that's going to have any type of energy absorption is going to be in synthetic materials. If it's a chain or a wire, there's no absorption in that. So in the event that you accidentally maybe have a little bit of dynamic loading, you may be able to absorb that dynamic load in slings versus translating that dynamic load in chains. So those are kind of the reasons why they get. Like I said, dead eye slings for me, my go-to attachment is come down, do a half hitch, come down a little further, and then do like either a running bowline or a closed clove hitch, something like that. So I kind of have a spinal cord column attachment that way. And you really can't accomplish that with chains easily.
Okay. If you were looking for more training on cranes, where would you go for that?
Well, you can contact me directly at travis@ynoble.com, or you can visit njcraneexperts.com or ynoble.com. We offer open enrollment courses all the time throughout the country for crane operators. We actually have one coming up September 11th and 12th in New Jersey. So if you want to go up to New Jersey and get your operators certification, we've got an open enrollment class right now. Also, we're going to plug right now September 30th and October 1st. We're holding the first ever North American Knuckle Boom Grapple Saw Symposium, where we're for 2 days we're going to have a bunch of the grapple saw trucks running with methanol heads on them, having talks about grapple saws. People actually can come out for the second day, and you can sign up to actually run grapple saws. So if you're thinking about getting a truck with a grapple saw, you want to try it out first, you can come see us then for that event. We'll also be at TCI Expo. You can come talk to us there. We do offer training programs. Where we can work with you on familiarization of your unit. We can bring a trainer out for 5 days or 2 weeks, and they can spend time in the field. All of our training is field-based training, so you're still doing production. You're not shutting down your operations to lose production, but you're actually learning in real-world scenarios. We have found with our training a lot of times the classroom doesn't translate to real world because your setups are different. You don't have the obstacles to deal with in real time in the classroom. So all of our training happens in with a field aspect to it. We'll come out, we'll set up a training package that fits your needs and fits your budget. Get you a pro level trainer that's going to spend time in the field where you can be efficient, learn on the job, make some, get some production done, as well as make your crews more efficient and safer.
Fantastic. That sounds great. I also want to plug that you have done a couple other webinars on cranes. One where we actually got out the little toy crane and did some
Yes,
lifting.
you can still see it sitting on
Oh,
my
it's still over
bookcase
there?
up top there.
That's a great thing. I need to get one of those. But yeah, so if you go to either our Facebook or YouTube channel at Tree Stuff, you can find those that he did. Fantastic training. It's going to go over some of the different stuff, some of the things that he talked about today, because it's really important. But yeah, I'd recommend checking that out too. Fantastic. I think I have one more question, and then we'll get out of there, get out of
Yep.
here. How do you feel about rope slings such as the Crane Man Inc. ring with rope slings? From John
I've
Bells.
never I've never run it personally, so I can't speak to it. I can't tell you I have any personal experience with it.
Mm-hmm.
The slings I have a lot of personal experience with are the Tough Flex endless round slings, the Teufelberger Mark Chisholm crane kit, which is the Deadeye slings, and I've used some wire rope slings and those kind of things and some chains, but I've never used the Crane Man sling. Um, if you got one you want to send to me, I'd love to try it out, but I just never used it, so I can't really speak to it. Um, Sorry, I wish I could. I hate I can't give you a better answer than that. So
That's fine. All right, great. Well, thank you very much for doing this again. Always great to have you on here, and and making this great resource for everybody.
yeah, no, it's a pleasure. Thank you, Tree Stuff. Thank you all those who tuned in or who are going to watch this afterwards. Thank you, Noble Oak Safety and Training and NJ Crane Experts. It's really an honor to be a part of the industry and continue to help educate and keep people safe. I truly believe that we are a family in this industry is what I love about it, and I love being able to help each other out. So feel free to reach out to me anytime at that email address that's listed here. Even if you don't want to like hire us to do anything, you just want to talk, shoot me an email. Love to talk to you, love to get to know you and see how what you're doing in the industry. Also, right now we are looking for trainers. If you feel that you have a ability to train others, especially if maybe bilingual or have another language that you can speak, French like that, we'd love to have you. Put in an application. You can find our applications at whynoble.com under the team page. At the very bottom, there's an application link there. Feel free to fill out an application if you think you want to be a trainer. We'll assess you and maybe get you on the team.
All right, fantastic. Have a nice night.
Take care. Enjoy that steak, Kale.
Oh, I will.